Hi, today we'll be learning about diffusion, which can be explained by the kinetic particle theory. These are the success criteria that will be covered in this lesson. Make sure that you are able to check off the success criteria at the end of the lesson. Okay, now diffusion is not a new term to you. You have learned about it in your lower secondary sciences. Now the reason why when you step into a shopping mall that has Starbucks coffee, right? You can actually smell the aroma of the coffee from a far distance, right? This is due to diffusion. Similarly, when you walk past a bakery, you can smell the aroma of freshly baked bread. This is also due to diffusion. Now let's try to recall the definition of diffusion that we have learned in lower secondary science. Is this the definition that you have learned? Right. In chemistry, we are not particular about the detailed phrasing. Hence, as long as you include the main points that I'm about to cover later in your answer, it is fine. You need to tell me that it is a process by which particles move to fill up any available space from a region of higher concentration to a region of lower concentration. Now, diffusion will enable us to achieve a homogeneous mixture. By homogeneous, we mean that we have equal concentration of the particles within the space that we are looking at. Now, let's watch a video to better appreciate the concept of diffusion. As you watch the video, keep these 4 questions in mind. What is the color of bromine gas? What are the particles undergoing diffusion? What happens when the cover is removed? How long does it take for equilibrium in concentration to occur for this particular setup? Right, without further ado, let's go to the video.
You can see diffusion happening on a small scale in the lab, using bromine, an orange-coloured gas. Place a jar of air on top of the bromine, and it slowly starts to spread. It's moving up the tube against gravity. Over time, the 2 gases mix. After half an hour, both containers have a uniform colour. It takes time because the air and the bromine molecules are colliding with themselves and each other.
Right. So, what is the color of bromine gas? From the video, they described the color as orange, but in your textbook, we used the color reddish brown. So either color is fine as long as you are consistent in your usage. Second question, what are the particles undergoing diffusion? Now, the particles that are undergoing diffusion is not just your bromine gas. Although bromine is the one that is visible to our eyes, there are air molecules present in the upper glass jar as well. So the upper glass jar, right, the air molecules will move from the upper glass jar to the lower glass jar by diffusion as well. So both air and bromine are moving randomly and they are diffusing from the region of higher concentration to a region of lower concentration. Third question, what happens when the cover is removed? You would have noticed that when the cover was removed, the bromine particles begin to diffuse into the upper glass jar. Okay, so this is what we observe, diffusion of bromine particles. Last question, how long does it take for equilibrium in concentration to occur? Equilibrium in concentration occurs when there is equal concentration of bromine gas in the upper and lower glass jar, as well as when there is equal concentration of air molecules in the upper and lower glass jar. And this happens in half an hour. Okay, so by now you should be able to describe diffusion, and you should be able to cite evidence from the given example to show that diffusion has taken place, as from the glass jar experiment of the bromine gas and air molecules. Last but not least, by now, you should be able to explain why is it that we are able to smell Starbucks coffee from a distance, and why is it that we can smell the aroma of freshly baked bread from a distance. Okay, that's what we have for this lesson. Thank you.